Okay, my dear. So last time we were doing the topic electrochemistry. You know that. So today we are going to start with the next part of the electrochemistry, that is electrical method. Electrical method to prove the Avogadro's constant. Okay. So we are going to start with the electrical method to prove the Avogadro's constant. You know that Avogadro's constant, it is having the constant value 6.02 times 10 raised power 23. But now we are going to prove it that its value is 6.02 times 10 raised power 23. For that purpose, my dear, what we have to do, we have to do an experiment. This is a beaker. Okay. So in this beaker, you have to take an electrolyte. So the liquid thing present in it, that is called as the electrolyte. So the electrolyte used up here, that is called as the copper sulfate solution. So copper sulfate solution, that is the name of the electrolyte, and this electrolyte is having the two rods inside it, like that. Okay, so these are the two rods. These rods, they are made up of copper. So this is copper, and this is copper as well. Okay, so these rods, they are attached with the battery. So this is the symbol of the battery. This is positive, this is negative terminal. Okay, so with the negative terminal or positive terminal, you can attach an ammeter up here. Ammeter. This ammeter, my dear, it will show you that how much current is flowing through the electrodes. So the positive terminal, this thing that is called as the anode. So this whole thing that is dependent on the electrolysis. It's not the electrochemical cell. Electrolysis, that is the reverse of electrochemical cell. Up here, battery is present. With the positive terminal of the battery, the rod attached, that is anode. With the negative terminal, the rod attached, that is called as the cathode. So this is the cathode. Okay. Now this is actually the electrolysis. Okay, so how we are going to operate this one? Okay, first of all, my dear, we have to see the electrolyte. That which electrolyte is present up here. You have to make the ions of that electrolyte. Okay, so just read the name of electrolyte. This is copper. So copper is +2. Then you got sulfate. Sulfate SO4 -2. And then the word solution is written. It with the name of electrolyte, solution, concentrated, dilute, or aqueous. If these four words are written with the name of electrolyte, so you should make the ions of the water, and the ions of water are H positive and OH negative. Okay, so these are the ions of the electrolyte. So this is your step one. Now we have to move towards the step two. We have to see the type of electrode. Okay, everybody just look up here. These electrodes, they are made up of copper. This is made up of copper. Okay, so you have to see in the electrolyte, the copper ions are present. If the electrodes, they are made up of a material whose ions are present in the solution, so these electrodes, they are called as the reactive electrodes. And in the reactive electrodes, the ions in the solution, they do nothing. They would remain in the solution. Okay, all the work that is being done by the anode and cathode. Yes, yeah, you.
सर मैंने बेसिकली अभी ज्वाइन किया तो मैंने पूछना था अभी आपने इससे शुरू किया है या इससे पहले भी आपने कुछ करा है
बिल्कुल ये पहला टॉपिक शुरू किया बेटा
ओके सर थैंक यू
दिस इज द इलेक्ट्रोकेमिस्ट्री नेक्स्ट पार्ट ओके okay my dear so this is the reactive electrolysis in the reactive electrolysis what would happen at anode that is the positive terminal. At anode, the process of oxidation that would take place. Oxidation means loss of electrons. Okay. Whereas at cathode, okay, which is the negative terminal, at cathode, the process of reduction that would take place, which means uh, gain of electrons. फिर आप वो भी काटते हैं CO पॉजिटिव ऐसा कोई ना बेटा उसकी एक आदमी ने मैंने बताया कि ये रिएक्टिव इलेक्ट्रोड्स हैं रिएक्टिव इलेक्ट्रोड में जो सॉल्यूशन के आयंस हैं वो कुछ भी नहीं करते दे रिमेन इन द सॉल्यूशन ऑल द वर्क इज डन बाय दीस टू इलेक्ट्रोड्स ओके अगर ये इनर्ट इलेक्ट्रोड्स होते these are made up of a material whose ions are not present in the solution they were the inert electrode inert electrode do not take part in the reaction all the work is done by these ions positive ions cathode negative ions move towards the anode और वहां पे जाके इनका प्रेफरेंशियल डिस्चार्ज होता है जो तुम ओ लेवल में कर चुके हो ये वही चीज है ओके इनर्ट एंड रिएक्टिव इलेक्ट्रोलिसिस एनीवेज so what happens at the anode this anode my dear it is made up of copper atoms so these are the copper atoms okay at anode what would happen the copper atom would break down to form copper ion and electrons okay so it will break down to form copper ions and electrons. Okay, the ions would come in the solution, and the electron they are present in the electrode. So electron travel through the wires, would come in the cathode. Ion travel from the solution, and at cathode, what would happen? This reverse process would take place. Copper ions and electrons they form the copper, so the copper is deposited up here. Okay. So copper atom would be deposited on the cathode. Did you get it? So if you
Yes, sir.
yes, Uzair, you want to ask me something, madam?
नहीं सर मैं कह रहा था समझ आ गई है
Okay, so the anode that is going to dissolve, the cathode that is going to increase in mass. Okay, so this is the reactive electrolysis. Okay, now what we have to do basically, we are going to put a rheostat up here. So this thing that is the rheostat. I think most of you people are taking the physics. Okay, in the physics, you people have listened the name of the rheostat. What is the rheostat? Rheostat is a resistor. So it stops the current. Okay. So rheostat is the instrument which stop the current. Very less amount of the current passes through it. If you do not attach the rheostat, what would happen? The deposition of these copper ions to form copper on the cathode that is faster. Okay, so basically we have to take the mass, initial mass of the copper cathode and the final mass of the copper cathode. Okay, so the initial and the final mass of copper cathode. Okay, we have to measure it. If the deposition of the copper on the cathode is faster, so if you are going to remove the copper cathode, what would happen? There are the chances that the copper atoms could flake off. They could flake off from the copper cathode. Okay, so automatically your results they would be affected. So if you pass a small amount of current, the deposition of the copper atoms on the cathode that is rigid. It would not flake off. Okay, it would be rigid, it would remain, it would attach on the copper cathode very permanently. But if the faster deposition of the copper would occur, so the deposition that is not too rigid, that is not too strong. If you are going to remove the copper cathode, there are the chances that the copper layer that would be flake off. Did you get it? So that is why we put the rheostat up there so that less amount of the current would pass. Okay, and the deposition of the copper on the cathode that would be very slow. Did you get it? Sorry, you have been wording the lower level gaya. Okay, so now what we are going to do, my dear? So we have not passed the current yet. So what we are going to do before experiment. So before experiment, what we are going to do, we have to take the copper cathode. Okay. So we have to take the copper cathode. We have to wash this copper cathode with distilled water. Distilled water, and then dry it, and then take the initial mass of copper cathode. Okay. So take the initial mass of the copper cathode. Okay. This is the thing you have to do. Okay. With the copper cathode before experiment. Okay. Now you are going to attach it with the battery, rheostat, and ammeter and pass the current for 1 hour. Okay. After 1 hour of electrolysis, so after 1 hour of electrolysis. So after 1 hour of electrolysis, what you have to do? 1 hour of electrolysis. You have to take out the copper cathode again. So copper cathode, okay, and then you have to wash it with distilled water first of all. And then wash it with propanol solvent. Okay, and then dry it, and then take the final mass of copper cathode.
प्रोपेनेंट सॉल्वेंट जो है इसमें ऐड करेंगे जो फिल्ट्रेट बचे
जी
प्रोपेनेंट सॉल्वेंट जो है
ऐड नहीं करेंगे, उसमें वॉश करेंगे वो इसलिए because firstly when you take the copper cathode you have not entered it into the copper sulfate solution. Okay, firstly it has not entered in the copper sulfate solution. Before entering it into the copper sulfate solution, you have taken it and wash it with distilled water only, dry it and take the initial mass of it. After you have put this copper cathode into the copper sulfate solution, do the process of electrolysis for 1 hour. Okay, so after 1 hour, you have to take out the copper cathode. Okay, wash it with distilled water, then wash it with the propanol, then dry it and find the final mass of the copper cathode. Yeah. सर ये प्रोपानॉल से वो सर जी वही बताने लगा हूँ, ये कॉपर सल्फेट जो सोल्यूशन होता है ना, ये डिस्टिल्ड वाटर के साथ कई दफा उतरता नहीं है, जम जाए ना तो उसका उतरना मुश्किल होता है, तो इसीलिए हम लोग डिस्टिल्ड वाटर और प्रोपानॉल के साथ इसलिए वॉश करते हैं ताकि प्रोपानॉल में ये इजीली डिसॉल्व हो जाता है. दैट इज द रीजन. डिड यू गेट इट? यस. Okay guys, so now what you have to do, you have to subtract the final mass and the initial mass of the copper cathode and you could find out the increase in mass of copper cathode. Okay, so suppose the increase in mass of copper cathode. Okay, that is 0.178 grams. This is I'm going to suppose. Okay, it's not the actual value, so my answer that wouldn't be 6.02 times 10 raised power 23. I'm just telling you the method. Okay, after that when people would do the questions, then you would be able to understand it. Okay, and you pass the current. Okay, and that would be measured with the help of the ammeter. So let's suppose the current amount that was 0.5 ampere, and the time we passed the current, the time that is 1 hour. I've written up here, so 1 hour. Okay, now you people have to do the calculations. Okay, Okay, now we are going to do the calculations. The calculations, they are little bit same as we have done previously, but there is some difference. Okay, so first of all, you got the current and you got the time. So what should you do? You should find out the charge. Q is equal to I into T. Okay, so the I up here, that is 0.5. The time up here, that is 1. Okay, multiply by 3600 to make it into seconds, because 1 hour contains 60 minutes and 1 minute contains 60 seconds. Okay, so 3600, so it would become 1800 coulomb. Okay, so this is the charge. This is the first thing we have done. The second thing, whatever the copper cathode increase in mass, so you should change it into mole. So mole is equal to mass 0.178 divided by its AR, that is 63.5. So if you could solve it, 0.0028. 0028. So these are the moles of copper you calculated. So the two things you are being given, copper cathode, and you are being given the current, and you are being given the time. Okay, so these things you are being provided, and you have to find out the mole of the copper. You have to find out the charge. Okay, now you should. This is the first step. This is the second step. Now the third step, you should make the ratio in between those. So make the ratio, that is charge ratio mole of copper. Okay, it's not necessary that you always take the copper. You can take anything else. Maybe it should be some hydrogen gas or something like that, because we have started the experiment with the copper and that was originally done. This experiment was done. So that's why I'm taking these values. Okay, so charge up here, that is 1800 coulomb, and the mole you required for that, that is 0.0028. Did you get it? Now, for 1 mole of copper, how much coulomb charge that would be produced? Okay, so just do it, my dear. 1800 divided by this one. So what you will get? 1800 divided by 0.0028. Plus 6.43. 6.43 multiplied by 10 raised to power. Yep. 5. 5. Okay. So this is the charge in coulombs. Okay. Now this coulomb is equal to how much Faraday? I told you at copper cathode, this equation, this reaction occur. Copper plus 2 electron is going to form copper. So this reaction occurred at the cathode. I have written the equation. You can see your copies. Okay, so here 1 mole of copper has got 2 mole of electron. These 2 electron, that is equal to 2 Faradays, because I told you 1 mole of electron is equal to 1 Faraday. Okay, so you got 2 mole of electron for 1 mole of copper, so it means this coulomb charge is equal to 2 Faraday. So if you want to make it 1 Faraday, so this one would be X, so divided it with 2. Sir, it's 3.21 multiplied by 10 raised to power 5. 10 raised to power 5 coulombs, that is equal to 1 farad. Okay, so you have calculated this thing in 1 Faraday by using the equation. Okay, so this is your step 3. Okay, now you have to move towards the step 4. In the step 4, you should use the formula F is equal to L into E. The F that represents this one, 3.21 times 10 raised to power 5. L is the Avogadro's constant. You have to find it out. E, that is the charge on 1 electron. And I told you last time, charge on 1 electron, that is 1.6 times 10 raised to power minus 19. So it will come on that side. 1.6 times 10 raised to power minus 19. If you solve it up, my dear, you will get the answer 2 into 10 raised to power 24. So this is the Avogadro's constant, which has been proved. But my values, they are supposed value. So that is why the answer is correct. Okay, guys, I'm going to share a screen with you. So you people have to solve the question, whatever the question I'm going to say to you. Okay, so let's start with it. So you have to do question number this part, second part, C second part. Just do it and tell me the exact answer to three significant figures. Okay. Come on, guys. One of the student he has calculated.
Sir, I got
What you got, beta?
5.97 into 10 power 23.
Yeah, it's perfect, beta.
सर जी मेरा भी यही आ रहा है
हमारा भी यही आ रहा है. What about you? Yeah, yeah.